Dear students, in this video we will understand the definition of a function, what is a function, domain and range, all those things we'll understand in this video. Dear students, I have made a separate video on introduction to relations. Before watching this video, I recommend you to watch that video and then watch this for the better understanding of this concept. Now let us check the definition. A relation F. This means function is also a relation, or it is a rule, or it is a mapping or a correspondence. Function is also a relation, a special relation from set A to set B, and this is said to be function with a condition. A relation is a function with a condition. What are those conditions? Every element of set A, that is every element of the domain set A, should have one and only one image in the set B. That means every element in the set A should have an image and it should have one and only image in the set B. Set B is what set? It is the codomain set. There are two conditions here in the same sentence. We'll understand this more clearly. When we say every element of set A, that is this set A itself becomes the domain of A. No element of the set A should be missed out from mapping. Every element should have the image or should have a mapping with an element in B. Now another way of understanding this is every element of A appears as the first element in the ordered pair. That means if you write the ordered pairs like this, when we list out the ordered pairs, every element from the domain set should appear in one ordered pair and it should appear in only one ordered pair. That is the meaning. That is, no distinct ordered pairs in F will have the same element. That means there cannot be an ordered pair like this. Every element should appear as the first element in the ordered pair, but it should appear only once. It cannot appear like this. This is not possible. If it appears, then it becomes a relation. It will not be a function. If it has to be a function, then every element of the domain should have an image and it should have only one image. That is the condition for a relation to be a function. How do we write the function? How do we represent it? F is a function from A to B. We clearly understand this, that A is the domain set and B is the codomain set. Now suppose if we write the ordered pair like this, x comma y. When we write the ordered pair like this, if it belongs to the relation, or sorry, if it belongs to the function, then x obviously belongs to the domain set and y belongs to the codomain set. And we have understood this similar concept in relations, that is y is the image of x, that is this happens to be the image of the domain element and this happens to be the pre-image. This is what we have understood. And how do we write it? F of x is equal to y. We have understood there is a function and mapping happens. There is a certain way the function is defined and that function is applied to the domain element and we get the result as here x comma y are variables. X is independent variable and y is dependent variable. X is an element from the domain set. It has no conditions. It just belongs to the domain set. But Y is an element in the codomain set. It depends on two things. It depends on the value of X and it also depends on the way the function is defined. So Y happens to be the dependent variable always. This is by convention. We always take x to be independent variable and y to be dependent variable. We have just understood the definition of a function. Yeah, one more thing. A function again is a subset of A cross B. We had already understood in the relations that relation is a subset of A cross B. In this video, we are understanding that function is also a relation. So, it is also a subset of A cross B. Every function is a relation, but every relation is not a function. I repeat, every function is a relation, but every relation is not a function, because sometimes the relation may not satisfy the two conditions we have understood. So it remains a relation. So with the correspondence here, we'll check whether this is a function or a relation. Now, the very first condition. What is the very first condition we have understood? Every element of the domain set should have an image. Okay, let us check. Does the condition satisfy? Yes. Every element of the domain set has an image. Yes, the first condition is satisfied. Now, let us check the second condition. You check A is mapped to 4, B is mapped to only 1, C to 4, D to 6, E to 7. Yes, every element of the domain set is mapped to only one element. The condition is satisfied. This is a function. So we are writing this as this is a correspondence or the function from A to B. Now let us understand this part. A is related to 4. A is mapped to 4, and in this C is also mapped to 4. Now check the definition again. What was the condition? Every element of the domain should have the mapping. Yes, it has satisfied the first condition. Now check, what did it say? No element of the domain should appear in a second time in the second ordered pair as the first element. Yes, it has not appeared. Nothing is mentioned about the image. There can be an element which can have two pre-images, but an element cannot have two images, but an image element can have two pre-images. So this satisfies the definition of the function. Now let us write the domain. Yes, from the definition itself, what is the definition? Every element of A will have the mapping. So our domain set will be A itself always. Always. If it is a function, the domain has to be the first set from which the function is defined. Now let us check the range of f. Now range can be different from the codomain set. In this case, it is 1, 4, 6, 7. Now if you see 5, 2 and 3, they do not have any correspondence with the elements of the domain set. So they are in the codomain set, but they are not in the range set. Hope you've understood. Let us check the second correspondence. First condition, every element of A should have an image. If you check, C does not have any image. C is not mapped to any element of the set B. So this is not a function. This is only a relation. The third example, check the first condition. Yes, all the elements of the domain have an image. Yes, the first condition is satisfied. Now let us check the second condition. Every element should have one and only one image. Yes, A has only one image, B has only one image, C has only one image, D also has only one image. Yes, as you have seen this, 3 has two pre-images, well, which is possible. So this is a function. Now let us write the domain. Yes, domain as we have understood, it is A itself. So we'll write this as correspondence F. Range. Range happens to be a subset of codomain set 1, 3, 5. This is the range of this function. The last correspondence we'll understand. Now look at this. The first condition. Yes, the first condition is satisfied. All the elements have an image. Now let us check the second condition. Every element from the domain set should have only one image. Now look at this. A has 1 as the image and A also has 3 as the image. A has two images. It has appeared in two ordered pairs as the first element, which is not the definition of the function. Definition of the function say there cannot be two images for an element of the domain. So the second condition is not satisfied. You can see that a mapping like this is not possible, but a mapping like this is possible. An element cannot be mapped to two images, but two elements can be mapped to an image element. This is a function. This happens to be only a relation. This is a function. For it to be function, this is a valid mapping. Now we'll understand, given ordered pairs, how do we check whether this is a relation or a function? And how do we write the domain and range? This is an NCERT question. I always prefer to choose the NCERT questions as the examples. Now the first set of ordered pairs, let us check. First condition, let us assume the domain has only 1 and 2 as the elements. But look at this. Number 1 has 2 images. It has appeared twice. One has 3 as the image and it also has 5 as the image, which is not possible. This is not a function. This is a relation. Now second question. Now check the ordered pairs. Since the domain is not specified, we'll take all these elements are the domain elements. So we are not checking the first condition. Let us go to second condition. That is, no two ordered pairs should have the same first element. So let us check. If you can see, all first elements of the ordered pairs are unique. The first element is not repeated anywhere. So second, this one is a function. So how do we check? We just check the first element of the ordered pair and decide whether it is a function or not. If the domain set is not specified, if the domain set is specified, then we'll check all the ordered pairs and figure out that all the domain elements have an ordered pair or all the domain elements are in the first element of the ordered pair. Now we'll write the domain of this. Domain of this function is 2, 4, 6, 8, 10, 12, 14. This is the domain. Now range of this. Obviously range is the set of all second elements of the ordered pair. 1, 2, 3, 4, 5, 6, 7. This is the range of the function. One more example. A function is defined by f of x, and how is the function is defined? 2x minus 5. Function is a special relation with conditions. So write down the values of f of 0, f of 7 and f of minus 3. So let us write the value for f of 0. Now when we say f of 0, then how is the function in general written? F of x. Where does x belong to? X always belong to domain set, an independent variable. Now if this happens, this is nothing but y. Always we write it as y is equal to f of x. So this is the independent variable. In this case, 0 is the independent variable which belongs to the domain set. Where should we write 0? 2 into 0 minus 5, and this is minus 5. What is this? This is nothing but y. Where does y belong to? Y always belong to the codomain set or the range set. So how is the ordered pair? This is x, y. 0 is mapped to minus 5. So as 0 is the independent variable and y happens to be the dependent variable. It depends on the value of x and it also depends on the way the function is defined. Now second question, f of 7. F of 7 again. 7 belongs to the domain set and we'll apply this to the function. 2 into 7 minus 5. So 14 minus 5 is 9. Now where does 9 belong to? 9 belong to range set. So how does the ordered pair look? 7, 9. Whenever 7 is the domain element, codomain element or the range element or the image is 9. For this particular function I mean. Now f of minus 3. 2 into minus 3 minus 5. So this is minus 6 minus 5, which is minus 11. Now mapping is from minus 3 to minus 11. Independent variable and this is dependent variable. Now real valued functions. What are real valued functions? It is very simple. A function which has domain and its codomain as the either set of real numbers or subset of real numbers. Such functions are called real valued functions. Dear students, question for you is, tell me, is this a function or a relation? I have a representation of a mapping here. You just have to comment and let me know whether this mapping is a function or just a relation.